Hi, everybody. Welcome to Behavioral Psychology, Part 1. I'm Dr. Ryan Curtis, and I'd like to thank Dr. Scott Roberts for the slides. Most of these come from him, and I appreciate the help. So the first thing we're going to do, though, is we are going to do a review question. This is a review from the methods part of the class. Here it is. Which of the following are true about operationalizations? All right, so let's look at these options. A, we can operationalize mood by showing some participants a happy movie and others a sad one. We can operationalize happiness by randomly selecting people to be in our study. We can operationalize a drug by having everyone in the study take a placebo. We can operationalize the Rosenthal effect by using a double-blind study. None of the above. The correct answer is A. We can operationalize mood by showing some participants a happy movie and others a sad one. If you remember, an operationalization is either a measurement or a manipulation, one or the other. So we're going to measure it or we're going to manipulate it. So in this particular case, A is a manipulation of mood. We operationalize the mood by having some participants see a happy one and others see a sad one. That's how that goes. B, randomly selecting people to be in our study. That's not operationalization. That's sampling. That's how we sample people. That's how we get people in the study. We can operationalize a drug by having everyone take a placebo. If everybody takes the placebo, then that's not a manipulation. That's just everybody took the placebo. That's a control variable if you call it like, if you want to think of it like that. You operationalize the Rosenthal effect by using a double-blind study. No, you get rid of the Rosenthal effect by using a double-blind study. You don't operationalize it. So the correct answer is A. You can operationalize mood by showing some participants a happy movie and others a sad one. Today we are talking about behaviorism. Behaviorism has to do with the idea of learning. Now, but by learning, I'm not talking about like education learning. I'm talking about behaviorism learning. If you remember, we talked about the learning theory earlier. The learning theory has to do with we learn to do behaviors based off of the outcomes that come from that behavior. So that's what we're discussing in this particular chapter. We're going to do several different activities. I'm going to move forward on this one because we're going to do this in two different parts. So the first part, though, is we need to talk about the difference between classical and operant conditioning. When we talk about behaviorism and learning, normally we're talking about conditioning. That is classical versus operant conditioning. And you shouldn't think about this like education. Remember, this is not kids in third grade that we're discussing here, though they do learn this way. But we are talking about, think of like a normal, like an animal, any organism. In classical conditioning, what we do is we make a behavior happen, a natural behavior happen for an unnatural stimulus. So a natural behavior occurs from an unnatural stimulus. Now, don't think about this like with humans. Don't get yourself too complex. Think of something that an animal does without you even doing anything, something they do instinctually. We'll get to Pavlov in a little bit. So let's think about this. Do rats chew naturally? Is that something they naturally do instinctually? The answer is yes. But do they normally chew like that when they hear a doorbell ring? No. The learning is now they get that behavior, chewing, when they hear ding dong, they hear a doorbell ring. That's classical conditioning. In classical conditioning, the behavior, chewing, is something that happens naturally, instinctually. It's just now happening for an unnatural reason. In operant conditioning, we get brand new behaviors. So the most famous operant conditioning scientist is B.F. Skinner. We'll talk about him later on. But by a new behavior, I'm talking about, have you ever seen like those YouTube videos? You got like this, this cockatiel that's like skating on skates. Do cockatiels skate in the wild? Is that something they instinctually know how to do? No, it's not. It's a brand new behavior. And to get that, we have to use operant conditioning. So classical conditioning, the outcome behavior is going to be in classical conditioning, the outcome behavior is going to be a natural one, an instinctual one. It's just going to happen for a new reason. In operant conditioning, that behavior, the outcome behavior is totally new. It's a new one That hasn't happened before. In this video, we're mainly going to be talking about classical conditioning. We'll talk about operant conditioning in the next video. Pavlov and his crew. So this is actual picture of Pavlov and the crew in doing their tests on dogs. So Pavlov was actually got the Nobel Prize in medicine. There's no Nobel Prize for psychology. So he actually got the Nobel Prize in medicine. And what he was looking for was really to understand ideas of salivation and salivation glands. So what was really going on with these dogs is that they surgically moved the salivation, I don't know even what you call it, the way the dogs salivate, so that the drool came out of their chin into a little test tube and not into their mouth. And that way they could measure exactly how much was going on. And they would harness them into these harnesses so the dog couldn't move and couldn't go anywhere. And what was happening is they were trying to figure out how that salivation worked, and they figured out that the dogs would start to salivate before they even gave the food, because they learned different cues, like a door opening, and then they would start to drool because they knew they were about to get the food. All right. So when we look at this, we need to talk about classical versus operant conditioning. In classical conditioning, the outcome behavior is a natural, instinctual one. So think about this. The outcome behavior here is drooling or salivation, same thing. Do dogs drool naturally? And the answer is, of course. Of course they do. Dogs drool naturally. But do they naturally drool when they hear a bell? Not normally. They had to learn that through conditioning. Now, I think, let me go back to this. We're going to draw this out really fast, because in classical conditioning, there's some terms that you should know, and they're different than the operant conditioning terms. When we're going to talk about today is unconditioned stimulus, unconditioned response, conditioned stimulus, conditioned response, and neutral stimulus. Now, those things are just for classical conditioning. They are not for operant conditioning. They're just for classical conditioning. So if you're asking if you see a classical conditioning question and it says, oh, what is positive reinforcement here? That's not the right answer, because positive reinforcement's for operant conditioning. Classical conditioning is unconditioned stimulus, unconditioned response, etc. But instead of unconditioned stimulus, we just normally say UCS. Conditioned stimulus, CS. Unconditioned response, UCR. Conditioned response, CR. Neutral stimulus, NS. So here's how this goes. The first thing you need to figure out is the unconditioned stimulus, the UCS. The UCS, sure I got a U going on there. The UCS is the thing that naturally causes the UCR. Okay, so in Pavlov's experiment, the UCS is meat. And the UCR is drool. All right? It is totally normal for a dog to drool, that's the reaction, when it encounters the stimulus, meat. Okay? Meat leads to drool, naturally. You haven't done anything here. That's totally normal. That's totally normal. What we're trying to do here, though, is we're trying to get, instead of a UCR, we're trying to get a CR. Well, guess what? The CR and the UCR have to be the same thing. Drool must be the UCR and the CR. Now, what are we talking about here? Well, here's what happened. Pavlov and his crew got this NS, a neutral stimulus. Now, the neutral stimulus in this case was, it was actually a metronome, but we always say a bell. I don't know why. I guess we did it with the bells later on. The neutral stimulus is the bell. So here's how this goes. The dog is in its harness. They ring a bell. Then they present the meat powder. It was actually meat powder instead of actual meat. It was, yeah, anyway, meat powder. And the dog starts to drool. Ring a bell, give the meat, drool. Bell, 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 meat, drool. And then pretty soon, you end up with bell, drool. What you're doing is you're pairing, we call that word pairing. You're pairing the neutral stimulus with the unconditioned stimulus. You're pairing the bell with the meat. And the more you do that, every time you do that, the more you do that, pretty soon you don't even have to give the meat. Instead, the bell becomes the CS. We call that conditioned stimulus. It's the conditioned stimulus because now the bell is the stimulus that gets the response by itself. The bell causes the dog to drool. At first, the dog would only drool when it encountered the meat. But when we paired the bell with the meat over and over and over again, pretty soon the bell by itself led to the drool. When we are talking about pairing, we're talking about pairing the neutral stimulus with the unconditioned stimulus. Bell, meat, drool. Bell, meat, drool. Now in that particular case, that's what we call a forward pairing. When you present the neutral stimulus first, the bell, before the unconditioned stimulus, the meat, that's a forward pairing. Remember, forward, like it goes in alphabetical order, if you want to talk about that. NS comes before UCS, right? Neutral comes before unconditioned. That is a forward pairing. Now, you can actually do those at the same time, simultaneous, but the actual most effective way to do this is a forward short delay. By forward short delay, I mean do the bell first, and then immediately after, like short delay. When I'm talking about short delay, I'm talking about less than a couple seconds short delay. Bell, meat, right? Bell, meat, and then the dog will drool, okay? The pairing, the forward pairing is the neutral stimulus first, the bell, and then the unconditioned stimulus. That's a forward pairing. A backward pairing would be if you gave the meat first and then you rang the bell. The delay between those two things is either going to be long or short. And long is anything more than a few seconds, right? So if you're doing like more than like 10 seconds, you're probably into long delay territory here. All right? Okay, so let's test you out. In Pavlov's experiment, the meat is the unconditioned stimulus. It's unconditioned because dogs naturally drool when they have meat. It's unconditioned. All right? Okay. Let's keep going. Do you have a food aversion? Right? I mean, what I'm talking about is there a food that you can no longer eat? Now, I'm not talking about you have an allergy. I'm talking about there's something that happened in your life where now you can't eat this food anymore. And if you do have a food aversion, what is the food that you can't eat? Okay. The Garcia effect is an example of classical conditioning. It is when we create a food aversion using our classical conditioning. Now, the Garcia effect is particularly useful because you can actually have a backward long delay pairing and only do it once, and then you've got a classical conditioned response, and for the rest of your life you can't eat a certain food. So let me give you an example. I was asking some students about this, and so let's go through the different parts of a classical conditioning study. All right, so here's what normally happened. I was talking to a student, and she said, oh yeah, so I was eating these goldfish crackers right before I had appendicitis. And so I was eating the goldfish crackers, but then I had appendicitis, and now I can't eat goldfish crackers anymore. Okay, you follow me on this? So I want you to think about it. What would be the UCS in that story? The UCS has to be the thing that naturally causes the response. All right, now remember the response in this case, we're going to start with the UCR. The response is going to be sickness, all right? Specifically, the desire to puke. So let's just make it clear, puke, all right? The reaction is puke. Well, what causes you to puke? Well, you don't have to learn this, but if you get appendicitis, you're going to puke, right? Or you're going to at least want to. So, see if I spelled that roughly incorrect. Appendicitis, okay? Appendicitis naturally causes people to puke. It's an unconditioned stimulus that naturally causes you to puke. What normally doesn't cause you to puke is a neutral stimulus, like goldfish, crackers. And specifically, I want them to be goldfish. Let's see if I can make this work. Okay. Goldfish crackers don't naturally cause people to puke. However, what happened in this particular case is she had appendicitis. She was eating the goldfish crackers. She was feeling really sick. And then what happened is this goldfish crackers became, whoops, let me get rid of that line that I accidentally put on there. The goldfish crackers became a conditioned stimulus. Now, whenever she encounters goldfish crackers, she gets a conditioned response. And what's that conditioned response? Well, she wants to puke. That's what's going on. So what happened was the neutral stimulus, goldfish crackers, was connected with appendicitis in her brain, and now goldfish crackers has become a conditioned response and makes her want to puke. She only had to do that once. She didn't have to go goldfish crackers, appendicitis, puke. Goldfish crackers, no, she only had to just eat the goldfish crackers. She could even eat the goldfish crackers a long time after she had appendicitis, and she could still get this to happen like for the rest of her life. That is the Garcia effect. Garcia effect is a form of classical conditioning where you create a food aversion. It's particularly interesting because you only have to do the pairing once, and it lasts for your entire life, and it can even be a backward long delay, which is a really rare way to normally do a classical conditioning pairing. All right, let's keep going. So those are some foods that you could have. So let me keep going on this. All right. Still talking about classical conditioning. I want you to tell me, are these different animals? Well, the answer is these are. The one on the left is a wolf, and the one on the right is a Siberian husky. They look similar, but they're not the same. Stimulus discrimination is when you have a classical conditioning that happens, but you are able to discriminate the conditioned stimulus from a similar stimulus. So let's say that you had a really bad experience where you now associate wolves with panic, right? So let's say that you were locked in the zoo with a wolf and you started to panic. You were panicking because you were locked in the zoo, right? But the wolf just happened to be there. If you panic when you see a wolf, but you don't panic when you see a Siberian husky, that would be stimulus discrimination, because you're able to discriminate the actual stimulus from something similar, the wolf from the Siberian husky. In the Garcia effect, here's a good example. Remember that girl I was telling you about with the goldfish crackers? She could eat other crackers, right? So she could eat Cheez-Its, that was totally fine. She only got sick with goldfish crackers. No other shape, no other taste. So all the other crackers were totally fine. She had stimulus discrimination. Even though other crackers are similar in color or similar in taste, she was able to distinguish them, and she didn't get sick with anything except for goldfish crackers. That's stimulus discrimination. Stimulus generalization is kind of the opposite. For this, we're going to talk about little Albert. So Watson is a famous scientist who did this study with little Albert. Little Albert was a young child when this was done, and this is actually a little bit controversial because we weren't particularly ethical. We, meaning Watson, wasn't particularly ethical in the way this was done. It was a long time ago. So here's how this goes. Number one, you need to know that kids are not naturally scared of white rats. So you see little Albert there, and little Albert doesn't seem particularly scared of a white rat, right? The white rat is a neutral stimulus. It doesn't cause any response. However, a loud noise does. And so here's what they did. They had little Albert. Little Albert's the baby, not the rat. Little Albert's the baby. They presented a white rat, and then they would bang a piece of metal right behind the baby's head. Babies naturally do get scared when they hear loud noises. And so they would present the rat, noise, and then the baby would get scared. Albert would get scared. Rat noise scared, rat noise scared, rat noise scared, and then pretty soon, all they had to do was present the white rat, and little Albert would freak out. What they did not expect, though, is that pretty soon, little Albert started to become scared not only of the white rat, but anything that was white and fluffy, including a Santa Claus mask. So they never did, Santa Claus mask, noise, freak out, right? That was not going on. They only did the white rat. But what little Albert did is little Albert generalized from the conditioned stimulus, which is the white rat, to anything that was white and fluffy. So now he's going to get that conditioned response, which is the fear response, every time he encounters anything that is white and fluffy, because he generalized the stimulus. He generalized from the white rat to anything that is white and fluffy. All right. Review question, here it is. In the case of little Albert, the white rat is the neutral stimulus and the conditioned stimulus. Before the pairings were going on, it's a neutral stimulus. But then after the pairings happened, it became the conditioned stimulus. So it is both. Do you have a phobia? And if so, what is your phobia about? What do you have a phobia of? You don't have to tell me, by the way. Well, it turns out that people are often creating phobias based off of classical conditioning. Just like little Albert created a phobia, a fear response whenever he saw anything white and fluffy, we sometimes do that ourselves. And so sometimes, in order to get rid of a classically conditioned response, like a phobia, we use habituation or systematic desensitization. Now, there's other ones as well, but these are easy to understand. So habituation versus systematic desensitization. We're going to talk about these and talk about how you can get rid of that fear response, or whatever the response happens to be, either through habituation or systematic desensitization. So let's take an example of a dog. So the first example is a dog, and the dog is afraid of thunder. Whenever the dog hears thunder, it starts to panic, it starts to run around, be very upset. Habituation is when you take the dog and all you do is you just make that thunder noise over and over and over and over and over again. So the dog's afraid of thunder, and all you do is you just chase the dog around, making thunder noises over and over and over and over again until the dog gets habituated and realizes that that noise isn't going to hurt it. Once that happens, you can get rid of the phobia. You get rid of the classically conditioned response. So habituation is just you put them in and you just flood them. Now we're not going to distinguish flooding from habituation, but you basically flood the organism with the stimulus over and over and over and over and over again until they realize it doesn't have to cause that response. That's a lot different than systematic desensitization. So some of you probably told me that you have a phobia of spiders. So let's imagine that you had a phobia of spiders. If you had a phobia of spiders, habituation would mean I put you in a closet with 100 spiders. That would be habituation. Now, some people don't think that that's particularly ethical to do. So instead, they systematically desensitize you to the stimulus. What we might do is start by thinking, this is you. You are afraid of spiders. We start by presenting this little cartoon picture of a spider. All right, I present that, and you say, okay, look at the picture, and you look at it until you no longer have that fear response. And then we start getting closer and closer to the real thing systematically. The desensitization is we're looking at this stimulus and we're no longer encountering that fear response. So start with the picture, then we go to this little toy spider, right? And if you're okay with the toy spider, then we move to another toy spider that's a little bit more realistic. Until finally we get to another one that's a little more realistic. And then finally, after all that, we actually have you encounter a real spider. That would be systematic desensitization. We start with something that's only vaguely similar, then we get more specific, more specific, more specific. And after you have been able to separate the response from that stimulus on each one, then we get you closer. All right. We're going to go ahead and stop there.